Today, let's look at this interesting and challenging question from NMOS 2022 Special Round and the last question. The description of the problem is quite simple. We have a trapezium ABCD with right angles at A and B. Now we pick a point E on AB such that the triangle CDE is an isosceles right angle triangle. And given that the length of BE is 20 and the length of CE is 52, we are asked to find the area of AED. We will provide two different approaches to this question. One is with Pythagoras theorem and one is without Pythagoras theorem. Please have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
There is an interesting observation on this diagram. That is, for the triangle AED, we can do a rotation and reflection, and later on it will come to this triangle. Say this is F. First, note that the triangle ADE is congruent to the triangle FCD because the angle here the same, and the sum of these two angles ADE and FDC is 90 degrees. That's right, these two angles AED and FDC are the same. In addition, the hypotenuse of these two triangles the same. That's right, they are congruent, meaning that AE equals to DF and AD equals to FC. If we allow to use the Pythagoras theorem, then we will look at the triangle BCE. Using Pythagoras theorem, you know that BC squared will equal to 52 squared minus 20 squared. Since both number is multiple of 4, so this is 4 squared, 13 squared minus 5 squared. After a calculation, we know that this will be a 12 squared, and therefore BC equals to 48. So from Pythagoras theorem, we know that BC equals to 48. Now, if we let AE equals to X, then DF will equal to X because the triangle AED and the triangles FCD are congruent. And since ABCF is a rectangle, so AB will equal to FC, and this is equal to X plus 20, so this is X plus 20. And since FC equals to AD, this will be X plus 20. So with this, we can form a simple equation for BC and AF. Since they are the same, 2X plus 20 equals to 48, and therefore X is equals to 14. And therefore, the area of triangle ADE is equal to half 14 and 34. And that is 7 times 34. That is 238 unit square. So the answer for this question is 238. So this is the first approach using the Pythagoras theorem. Now we go to the next approach without the Pythagoras theorem. If you enjoyed this video, please like, comment and subscribe. So for second approach, we can't use Pythagoras theorem, and therefore we do not know what is the length of BC. So first of all, we want to find out what is the area of triangle CDE. CDE is an isosceles right angle triangle with the hypotenuse equals to 52. So we can actually redraw triangle CDE as such, and we can see that if this is C, D and E, this is 52. We'll see that this triangle CDE is only a quarter of a bigger square with the length 52. As such, the area will be equals to 1 over 4, 52 square. And this will equals to 26 square. This is 676. So that's important that we need to know what is the area of the triangle CDE. We are going to cut the triangle CDE in a few portions in this way. Let's cut this along the line here so that it is vertical, and E along this horizontal line, and this is 90 degrees. Now let's say if we let the area of triangle ADE to be equal to S, then we'll know that the triangle of DE, say G, will also equal to S. Then the triangle DEG also equals to S. We are going to redraw this diagram here. So the area that we want to find is these three portions. These three portions. Now you see that for this portion, DG is the base and height is X. So it is actually equivalent to say that this is the area. So these two orange triangles are of the same area. And this is the red triangle. And for the blue triangle here, the base is EG and the height is 20. So I can redraw it as the base is EG and the height is 20. And we see that the total area of this red, orange, blue triangle is equivalent to the total area of this red, orange, blue triangle. Now we know that if this is S, this will be also equal to S. And we also note that A equals to X, and this is X plus 20, this is X, and CF is X plus 20. Now, if we borrow some portion from the blue and we get it here, together with this orange and a bit of blue triangle, and it is actually half of the rectangle CFD and say D prime, right? And this will actually equals to the S again. What is this area of triangle that we borrow? The dimension is X and 20. So we have 20, then we need to minus X here. So we need to minus X. So say this is 20 and this is X. So this portion will be disappeared. Okay, and move to here. And again, the total area of red, orange and blue will be exactly the same. Now, what happened to this smaller part of blue color? Initially, it is X plus 20. And some X move to here, we have only 20. So the base now is 20, the height is also 20. So we know that this area is equal to half of 20 times 20, that is half of 400, that is 200. Alright, so now we finally find out that this total area will equal to 2S plus 200. And this is exactly the same as the triangle CDE, which is equal to 676. And therefore, S will equal to 676 minus 200 over 2. That is again give us 238 units square. And therefore again, we find out that the answer for this question is 238 using this second method. So this is two different approaches I have for today. If you have any different method, please let me know in the comment. That's all for today's lesson. I'll see you again next time. Bye bye.